So injector pockets, through holes, fuel rail mountings, everything up here. So yeah, we are completely done, other than the inside profiles now, which we've got to do, and that's going to be done in this video. Now, I mentioned I'd ordered some tools, or had ordered some tools in a previous video, and this is what we've ordered to do the inside. Now, this is another one. So basically, this small 10mm that I've done the parallel toolpath with on the OD of the runners, on the OD of the whole part pretty much. This is basically a bigger version of it. Now I've put it in a, what do you call these, like a power chuck, because I'm thinking that's going to be the best option. I have a couple of 16mm hydraulics, but this shank, obviously you can see it's got a reduced neck, and the length, let me just put this down because it's quite heavy. The length of this reduced neck from tip of the tool to here is 120mm, which is plenty for what we want. But the rest of the shank, I think, is 80. And if I put that in a 16mm hydraulic, which is here, we will actually can only go in there about 30mm, 35mm. So we're going to have this stick out, the neck, which is fine, but we're going to be out here. And I'm worried that we're going to have vibration. So I'm hoping that a bigger tool will be a better finish. We left 0.5mm on these wall thickness. And if I just rotate this, went the wrong way, sorry. You can see where our roughing toolpath finishes, and if you just look right down the bottom there where that step is, that's as far as we could get down when we were doing it with a 20mm end mill. We couldn't get any further. So I'm going to use the same toolpath that I did on here. You can see I roughed these out with step downs, and it was a really, even though it's roughing finish, it was really bad. I wasn't happy with that. So what I'm going to do is a really fine finish, because this was a different cycle. This was 3D boring, I think it was. I think we have to tilt at around 3 degrees to be able to reach everything we need to reach. I'll have a play around with that infusion. But yes, that is the tool. There's various other tools that people recommended, so thank you very much for the recommendations. There was recommendations of some helical brand tools. There was recommendations of ISCAR tools, Multi-Master, but some of them had long lead times, and I wanted to get this one dialed in. So Cutwell in the UK supply these YG IX mill. So it's a full carbide shank, 16mm diameter. That's a 17mm insert on the end, because these will take 16 or 7mm inserts, 220-degree radius insert, and it's got a reduced shank. I think it's like 15.5 or 15.4mm reduced shank. So that should be more than enough. If I show you there, that's the depth we're at so far, so we can get way past. It should do everything we need to do and more. Obviously it's a 17mm diameter tool, so we've got an 8.5mm radius, which is less than what we need to get in there. So it should do the job. So I'm going to program this infusion. I'm going to get myself some dinner now, because it's about 7 o'clock. I'm going to go get some food, sit in front of the laptop in the workshop, and try and program a toolpath. And when we're looking good, I'll show you the simulation, show you what angle we had to get to, tilt the rotary, because I don't have multi-axis toolpaths as a like an add-on extension infusion. Silly enough, I'd done the 7-day trial, as I mentioned before, and then we had problems sorting the trunnion out, and that 7-day trial, it expired. So that was an utter waste. I wish I didn't do that, because I could have needed it or made use of it. If I have to use multi-axis, I will have to pay the £150 for 1 month and do it that way. But I'm hoping we can just do it with stationary fourth axis moves, and just tilt one way, tilt the other way, and get it done. So we'll see. But either way, stay tuned, and I'll bring you back when we've got a toolpath sorted. Okay, so we've created a toolpath the same as what we done on op 1 of the part, op 2 of the part, when we roughed out the inlet tracts with a 16mm end mill. It'll be a 20mm end mill next time because we broke that 16. So we're doing a ramp toolpath with our 17mm carbide holder ball nose tool, but it's leaving a bit of material in there and I'm not quite sure how we're going to get away with getting it all out. We don't know how we're tilting this, in the sense of I'm guesstimating some angles and I've done a few bits and pieces, so we're getting a smooth toolpath all the way down the bottom that transitions, but we're not cleaning up everything. We left 0.5 stock to leave inside the runners, so this has got 0.5 to come out of it. Playing it safe at the moment, I'm doing a 2,000 millimeters a minute feed rate, which is quite fast. We're going to go down the full, that's 120 mil relief, reduced neck. I'm going to go down 119, but I'm keeping 0.5 stock to leave because I don't want to take anything off yet. I want to sort of see what tool marks it leaves. Now, unfortunately, I do expect to have a few issues getting this right. So I'm not running all of these. I'm going to run this one, see what we can do. Then I'll do whatever we can. I'll take material out. And then when this one's sort of kind of done, I'll move on to this one. And then hopefully 5 goes in, we'll get it right. Now, I'm not sure about Fusion 360 multi-axes because it might benefit me to get a better finish in there using the multi-axis toolpaths. Now, as I've mentioned a couple of times already, I let my 7-day trial run out without even using it. Kind of gutted about that. So I have to pay the £150 plus VAT for 1 month subscription if I want to now trial it. But I don't know if it's going to make a difference because I've never used it before. So I could say, oh, let's give it a go, £150. If it works, fine, I'm happy with that. That'd be great. But if it doesn't work, it's £150 for nothing because this is the only real job currently I'm doing like that, and it's not going to be, once I've done this one toolpath, obviously that's going to be it for a while. If it works, fantastic. If it doesn't, I haven't got the money to just waste to have a see what it looks like. That's why I'm so annoyed with myself that I let the 7-day trial run out. And it's a shame that they can't see that you haven't actually used it, you know, to go again. So we're going to run what we said now, a 6-degree tilt and leaving the stock to leave. So it should barely, give or take some alignment, it should barely touch the part. But we'll soon see. Also, this is going to tell us what our alignment was like. See, we're making a bit of a cut when I didn't think we would be. Let's just have a quick look to see how much we're cutting. See, on that back side, it's cutting quite a bit. I'm going to let it run. I'm going to let it run and see where we're at, because until I've got like a datum, I'm not really going to know where I'm at, unfortunately. So we got about 10-minute cycle. So we'll let this run and we'll see what it looks like afterwards. then we can see where we've got an error. Straight away, the fact it's touching on the back when it shouldn't really be touching at all tells me we've got an initial problem. But we'll let it run and we'll see how bad it gets as it goes down the inlet pump. Okay, so the tool bath has just finished. I haven't had a look yet, but considering it was meant to leave stock to leave, it was meant to do a stock to leave, it was doing a lot of cutting. Right, so we must be out of orientation or alignment in our y-axis. So if you have a look here, that's actually quite a nice finish, to be honest with you. But look how much we've and it was still meant to do our 0.5 stock to leave. Now if we took 0.5 off of there, we are going to be quite far out with our O-ring seal there. So you can see it's touched on exactly half the part. And we've still got big steps in this corner, but probably because of the 0.5 stock to leave. So on here we've got 1.9 millimeters. On this side we've got 2.7. So we're going to be down to about a 1.5 millimeter off of the O-ring there, which is going to be there or thereabouts, but obviously we don't quite know until we get rid of it all, I suppose. So what I'm going to do is I'm going to redo this toolpath with 0 stock to leave. I'll do it with no stock to leave, and then we're going to know where we're at, because this is deceiving. It's a shame that it isn't touching on, or that it is touching on one half and not on the other, because if I can get that to take out these corners, the bits that it's not touched yet, you can see it's got a little bit of vibration there. But it's very smooth. But you can see it. It's not as good as this one. I don't know what sort of step down path they've used, but they've got it obviously better than me, and they've got it in one. And I'm actually wondering if they've changed this, you know, because there's lots of things on this part that's been amended to suit that the tools can get in it, etc, etc. Now I haven't amended this drawing, but I am wondering if they've changed it when they machined it. I wonder if they have. The advantage they got is if they've done it, which I think he said on a 5-axis, obviously they're not going to have any errors in offsets. They're not going to have any offset errors. They've got a little bit of mismatch in here, but they're doing quite well. So, okay, so we'll have another look at these runners. We're doing some runners in here, and we're just probing the block for an op one in here. I'm going to come over to that in a minute. But with these runners and this piece here, we're all done, we're all finished as you've seen. But I've been using this set to have a look and see what finish we can get, where we can get the best finish. And we've got our result. So, you saw in another video that, let me just jog this, but I said I can't get down into the bottom of the part. Now, it turns out that wasn't the issue at all. It's actually more a case of, excuse me, it's actually more a case of when I'd done op 1 on the back of the runners, and I'm going to show you now on this sample set. So the guys who done these done them on a 5th axis. I've said that a few times. Now they've amended this drawing on their file. Obviously I didn't get given their file, I just got a sample design. No file, no toolpath, so doing that myself. Now they've amended certain stuff, and this was their sample, so they've got a few mismatches and a few bits and pieces that weren't correct, which is all well and good. But I've now changed the file to bring this dead straight down. So if you imagine, the tool will be square to this face, coming down 40 millimeters to give me a true straight down bore, so to speak. And what was happening was the walls inside this part, on this side and this side, actually came in. I never realised that. Now they came in ever so slightly, so when I did my toolpath with my Z-axis off of this face, so to speak, so it was square to this face, I'm actually come down, and where the edge has gone in, that's where I've gouged into the material, and it took me a little while to figure that out. So I was asking about the multi-axis toolpaths, and you know, I'm not getting in where I need to. That wasn't the problem. The problem was I'd already taken out material that I shouldn't have taken out. And I noticed that when I went back through the program and I'd done in Fusion 360, I'd done the stock comparison. So it shows up blue as material that's left on, excess material, and red as gouged material. And when I looked back, it was gouged material. So I traced it back, and it was literally from op 1, which is what this is going to be. So op 1 took too much material out. And now if you look in here, in these runners, you can see in that corner and that corner, it hasn't touched them corners because it already took too much material out. But you can see in the middle there, it's not going to be the greatest, but you can see in the center, it's okay. And it was because the shape was a little bit iffy. It's not iffy, someone's just kind of done the design of the product, and the person who's done the drawing and the design has not done it with tool access and tool paths in mind. So once I found the issue, I've solved it. I've gone back through the simulation. There's one little bit that's showing in red, but when you zoom in, it's almost like on an edge, and I can't get rid of that. So it's as good as I think we're going to get. So we've got nothing else I could really do with this because I took the excess material out. I can't put it back in, so I'm never going to get a perfect finish with my toolpath using this new tool all the way down there to show us the perfect finish. So what I've done was I've skipped along all 5 of these pulps, and I've tried different feed rates, different step downs and everything like that, and I've come across what is going to be the quickest one. So these are 10 minutes per pulp. Now, one issue that arises for me, which is easy to work around, but the program ends up too big for my machine. I could use, I could drip feed it by the RS232 port, but I'm not really into that, and I've never got too involved with it. Although I have checked it once on this machine and got it working. I've never set it up on here, even though I've got the cable, so I'm not really going to worry about it. When I get to this part, on the end of the product, I've done the programming, 5 pieces, and separated them, port 1, 2, 3, 4, 5. So there's no real dramas. So we tested step downs. So let me just turn these back. So this had like a 1700 millimeters a minute feed rate with a 0.5 step down. This one was similar, but I changed the smoothing because this old machine struggles with the faster feed rates in the tool parts. It ends up, you can't really see it when you're watching it, but you can hear it. And if you put your hand on the machine, it's really vibrating. So we needed to get rid of that. So I upped the smoothing. I give it a really wide tolerance, and that gave us that finish. Okay, if you were going to hand polish it afterwards, but definitely not what I want as a finished article. We've done this one over here, again with a better feed, a better smoothing tolerance, and a 0.5 step down, but you can see it was a little bit vibrating at 2000 millimeters a minute. And the one I've ended up on is this one. So you can see there, we've got a nice even step down. This is feeding at 1200 millimeters a minute, and it's done a lovely job. If I just tilt it up, you can see the other side a bit better. So you can see in there, that's a nice finish. But again, I can't do anything about the undercut that's already been done from the other side. So this here, I'm done with it. Even if I start taking a bit more out, I think I'm going to end up taking too much out down there. So I think I'm just going to pull this off. And I might clean out these ports by hand with a flap wheel and then a Scotch-Brite ball on the end of my drill or my air tool, just because I'll keep this on the bench as kind of like an example. So it's still, you know, still quite good. Nice to show someone one that you've made, you know, and have something to hand. The other issue I had, remember I said about this plate was originally dowel pinned and now it couldn't be dowel pinned, but it already had the bolt pattern on here. So I was going to have issue aligning it. Everything looked good when we were working from the side, but when we come up the top, it turns out we are slightly wonky. Now, this bit here didn't show up as too wonky, but something's out because you can see on our O-ring grooves, we got the nice wide 3mm bit there, and we narrowed right off here. And down this end, it's not quite as prominent. Now, one way to get rid of this, it works out, it's about 0.3 out, which is not really going to be noticeable when the plenum's on, because I think the plenum hole, I'm going to check whether the plenum hole is slightly smaller or slightly bigger, but you're not really going to notice it on that side of it. So what I will do is I won't put these O-ring grooves in until we've done these bores. That way, at least the O-ring groove will match the bore. So if everything's out by 0.1, 0.2, it's not going to cause you an issue with a product. Obviously, I will get it as good as I can, but if that is the case, visually, it won't look wrong. It can be out that little bit, but visually, it will look okay. So that's where we're at with these ports. So I've kind of got to leave it there for now and end the video on that note. Now, I will put up a secondary video. I say secondary, we've done about half a dozen of these, a dozen videos, whatever we've done. Because I'm going to attempt to do this in 2 ops now. So I'm not sure if this little HRT 160 is going to handle it for the braking capability. Weight-wise, they say don't put anything on it that's heavier than the 4th axis unit itself. Now, this is about 45 kilos, I think. So you don't want to put anything on that's more than 45 kilos in weight. Now, the stock material over here, this is 20 kilos. And what we're going to do in op 1, just losing my voice here. What we're going to do in op 1 is we're going to face it off. We're going to do this flange. We're going to drill our double holes like we did previously. We'll do our clearing and then our contour. So these will be finished 40 millimeters deep. They will be true and finished and done. Then we will drill and tap M6 as we've done before. 2 M10s drilled and tapped, and 2 dowel pin holes for this, and we'll finish it down to here. So this will be a finished face and a finished flange profile. So that will be good. Then what I'm going to do is, while it's in there and the material's orientated like so, I'm going to come down with a face mill I'm either going to sit the job like that, parallel face, resting on this back edge, hasn't got to be perfect, and rough away just a bit of material with a face mill. So you imagine, I'm not going to use this is a bit of a beast, but you imagine coming across there with a face mill, just a couple of passes or 2 step overs, and taking down the excess material, which I think was about 15 millimeters. So we've got rid of about 8 millimeters here, the material round, material inside, and then if I can take off about, I don't know, I'm sure it's 15 or 10 millimeters off of here, I reckon we can probably knock 2.5 to 5 kilos. I can't remember what we were after op 1. So let's say we're going to be around 17 kilos, for example, of weight. I plan to then bolt the whole block assembly onto here, as per we've done now, but using slightly shorter bolts, and then doing everything else in one hit on the table. Now, we will use the longer table, whether I make a sub plate or whether I do use this for the job. I think I may use this and do what some of you guys recommended. Once it's bolted and squared up, drill through it, drill it, counterbore the top section and tap it so that this plate stays on them ends, and maybe we'll use this for this one job. And then next time I make a trunnion table setup, I'll get these done out of steel and have the faces ground and stuff like that, because we need a bit more clearance at the sides, I think, than I've got here. I can check on the program, but also I already know that this bolt pattern is slightly out of line, so I really want to get that sorted. So that's where we're at. So I'm going to end the video here now on the series of machining the billet runners. Bar the interior bolts, that is the finished product. Now, I really appreciate everyone's help. You guys that have sent all your comments in, and you've messaged me, people have emailed me, WhatsApped me, all sorts. So I really appreciate that, and I wouldn't have got this far without the help from some of you guys, and along with the guys that's on a little sort of personal WhatsApp group we've got going on, or messenger group, shall I say, Doug and Ivan and Lee and Simon and all them guys, that when we're stuck at home and we're helping out each other out with bits and pieces and how to do this and how to do that. So I've managed to do these with the help of everybody. Definitely wouldn't have done them just by myself because I just don't have the experience, but I've learned an awful lot in the last week or so. So really appreciate that, really nice of you guys. And I will bring back, shortly, and we'll show you the video on the other block and how we're going to get there and finish the ports when we're done. So cheers for watching, see you again soon.